Um, we're going to look at systems of equations today, but with quadratics. So it's been a little bit since we've talked about systems of equations. Systems of equations, when you have two equations and you want to find out what value for x and y work for both of the equations. Now, if you think about it graphically, it's where the lines intersect each other. So we've done systems of equations before. I'll give you a little review because it's been a while since we've seen one. You don't have to write this, but like if I gave you this. Up here in this jar here, if you want to grab one. If I gave you this, that's a system of equations. We're trying to find the value for x and y that would work for both of them. And we learned two strategies. Remember the names of one of the strategies we've learned to solve them? Good. Substitution is one of them. Good job. And that's the other one. So substitution and elimination. This one I would do substitution. That's where like you find this, find what it equals, and plug it in. Remember that? So we're going to be doing that today. But the difference is last time we did it with these kinds of equations, which are linear equations, just straight lines. Today we're going to do systems of equations with quadratic equations. And as I mentioned, when you're solving system, you could think about the solution of a system as where the two lines cross each other. So we'll look at, these are 6 different scenarios that could happen in the problems that we're looking at today. But like if I graph 2 parabolas, it's possible that they could have 2 answers, 2 points where they intersect. Or they could have just one, or they might not intersect at all. Or we'll also look at where we have a quadratic and a linear function. Maybe they don't intersect. Maybe they intersect once. Maybe they intersect twice. So these are the different outcomes that we'll see. These two over here, where there's no solution, as you're going through and you're trying to solve, what's going to happen is you're going to end up with imaginary answers. If you get an imaginary answer, that means those 2 lines don't intersect. But otherwise, you'll just get a regular answer, and that's how you'll know. All right, so before we get into the more algebraically challenging parts, let's just take a look at this. Estimate the solution to the system of equations. Okay, so what I share with you guys is that the solution to a system is where the 2 lines what? Intersect. So that would be here and here. And each one of those points has an x and a y value. So what would you guys estimate that x and y value to be there? And you got to be careful because I think these lines are going by 2s, like 2, 4, 6, 8. What is it? 1, 4. Okay, that's this guy over here, right? 1, 4 over 1 up 4. And the other one? 2, 4. I like your 4, but it's actually going to be 9. And that's because we're counting by 2s, but there it is. So that would be the solution to the system. We have 2 values of x and 2 values of y. Okay? Now that's just like a graphical illustration of what we're doing today, but most of what we're doing today is going to be done with pretty much just doing some calculations. So let's go ahead and do this first one here. You could do substitution or elimination. I'm gonna go with a substitution approach. Okay. So do you guys see how this one is equal to y and this one is equal to y also, right? Since they both equal y, they must equal each other. Does that make sense? So if they both are equal to y, then they must both equal each other. So the first thing we're going to do is we're going to say this one must be equal to the other one. All right, so go and write that down. So now this is a quadratic equation here. And so when you have quadratics, you can't solve it by just getting x by itself. You have to use, what you want to do is you want to move everything to one side and get it to equal 0. So that'll be the next thing I'm going to do is I'm going to add x on both sides and subtract 4 on both sides. That way, I'm left with 0 on this side. And over here now I've got this. When you have a quadratic, you need to get everything on one side and have it equal to 0. Okay? All right, now step 2 is going to be the quadratic formula. One plus one. Now we're going to be doing the quadratic formula with this thing here. So the A is 1, the B is 2, and the C is 3. So that's the values we'll be using. I'm going to let you guys do the quadratic formula, though, just for the sake of practice. And then I'll ask you guys what you got, though. So I'll pause here and let you guys work that out. Now, with these problems, you could get weird answers, like weird square-rooted answers. I'm not going to give you those for these types of questions. Every time you do one, it should turn out to be just a nice number. So your square root should turn out nice and neat and not weird. So go ahead and work that out. I'll give you a little bit to find those x. So you guys should have ended up with two answers, x equals -3 and x equals 1. Now, with these types of problems, with these systems equations, I'll make sure that I'm giving you problems that work out nice like that. Of course, it could be one of those ones where you have like a weird square root. If you ever had one of those, I would say just turn it into a decimal and use the decimal. But I don't plan on giving you that. But I just want to let you know that it can happen. But I'm only going to give you ones that work out nice because if you get a decimal, if you get a weird answer, the next step's a little bit more work. So I wanted to avoid that. The next step is we need to find the y values. So I'm out of space here, so I got to write here. But the next step is to find the y values. We have two x values, x equals -3 and x equals 1. For each one of those, we need to find the y value that goes with that. Okay, so pick one of these equations. It shouldn't matter which one you pick, because remember, we're looking for the points that they intersect at, the points that they have in common. So it doesn't matter if I plug this into the top or bottom equation. They should both give me the same answer. If they don't, something's wrong. So I would say just pick the one that looks easiest. I think this one looks easiest. I'm going to plug that in and solve for y. So we have y equals -x plus 4. We have double negatives here, so that's a positive. And then we have 7. Same thing here with this guy. Plug in the 1. And I get 3. So the 2 points where these lines intersect are as follows. I'm going to erase this real quick. One of them, they intersect at -3, 7. That's one place where those two lines cross. And another place where they intersect would be 1, 3. Okay. So step 1, let's review. Step 1 is to set these things equal to each other. Set the two equations equal to each other. Step 2, after you move everything to one side and have it equal to 0, quadratic formula. Step 3 is to find the y values. What's up, Cal? The last thing that I did? Okay, I'll be with you in a little bit. Let me throw up the next thing here because I'm not too sure what you're referring to, but I'll come see. All right, so that's it. Now I've got a picture here, and those are the 2 points where they cross. So this is this line right here. That's this parabola, and then this one right here is this blue line, and they're crossing here and here. And I think we said the points were -3, 7, and 1, 3. So that's the places where they're crossing. So that's what we found by doing that. Okay. Now, once again, if you ever get an imaginary answer, what does that mean? There's no solution. That means the 2 graphs that we have don't intersect. So as soon as you see an I come into the picture, you can stop solving it and be done. You don't have to find Y or anything like that. So when you're doing your quadratic formula, if you get an I, just stop and be like, no solution. That's good enough. Okay. All right. So for the remainder of the class here, I'm gonna let's see. I'm gonna let you guys work on the guided practice here and the student practice. Okay. So do those 2, and we'll see how you guys are doing, and then that'll be it for the day. Okay. That's true. Yeah. So I mean, that's fine. Yes. So what was your question? Okay, so we have the square root of 16 is 4. And then we split it up as -2 plus 4. Minus 4. And we simplify both of those. We did the square root so far. Okay. You could try elimination and see how it works. So I'm just going to do, I would say just a substitution, but I mean, if you wanted to, what I would say to do is multiply the whole thing by negative, that way the y is canceled, and 0, it has to equal 0. But I would say just no. Yeah, no, we're not going to do elimination. I think the substitution method will be good enough for today.